Hello, this will be my third video, video three, and then there's an introduction. This will probably be my final video, unless anybody asks questions. Uh, it will be about explaining some details about the pictures and some interesting, well, the relevant facts, why this information is important and what it can do for science. Um, so I'll start with this Canis D dwarf galaxy, which is hidden from our view behind the disk of the Milky Way. I'll try not to stay on too much. The first thing I'd like to mention about this view of the galaxy is that it's at light speed. So, in a matter of speaking, what I'm seeing is what it looks like at speed of light also. So this is the energy, this is the shape that it makes in space physically, but we can't see it because there's dark matter, which is just this fabric of space-time, too full around here. You have to get either light speed or up close to under it, basically, to see this. This is a black hole, this artist here, the event horizon is right here. Time dilation is taking place right in this area. These are three fast tesselings from the debris trail, which is sucking, the Milky Way is sucking away the debris trail, and I'm going to get more into that in a later slide. This is the Milky Way is going one way, or the galaxy is rotating this way, and the debris trail is pulling away this way, so this is really hot matter. And this is an arm, which has been completely emptied of all its stars and dust and gas and everything. The only thing that's left is the shell, but it's still there, and there's actually a little piece of an arm starting to form, kind of like comes on and off like. And these are clouds. Over here is the disk where there is supercooled gas, and when the gas flows over it, it freezes. Just it's flung this way, and this light ray that I caught, so light wave that I caught, got pulled into this. This is an arm right here, and it just pulled it up into this little edge spike, and it froze. Like the light actually froze, and then layers left, and just gets flung around. So it's very tricky. And this is a very distinctive aspect of this galaxy. It's emptied. This is kind of where the deciling begins, and it was sound in the light wave also, so it sounds like it goes down. And then it also spread apart in the event horizon, down into the event horizon, down into the black hole. And I believe that this is a black hole, and this is a singularity, and it's normally a point of just an infinitesimally small point where basically there's a Big Bang right here, and that's the case in every black hole in the Milky Way and Solar Galaxy. Every black hole has a Big Bang. Some are bigger, some are smaller, and that's just the best way to describe it. It's a ignition of space-time itself and creating space-time itself. And it's more than a nuclear explosion. It's not fission. It's not fusion. It's fusion, not fission. But it's so energy is just perpetually being created here, and whenever the rest of the galaxy needs energy, it'll feed it. And around these edges is also part of the event horizon. It's just smaller and more compact. But anything that goes beyond this point goes into the singularity. And our sphere is all filled with space-time. It's just a second time. The debris trail pulls all the way down in here. It can't. It's not in this painting, but the black hole competes with material from the debris trail. There's a little tiny little structure in here that kind of is stuck in there. Another view of the light ray is bouncing off this third sphere, and there's a little reflection out of these flags. This is at near light speed. It's freezing cold up here. These are basically just clouds, and they all get arranged neatly on the side because there's certain energy levels in the whole galaxy. And there's a lot of space time that's bent down around here. It's pulling way down on the fabric of space, and that's the reason why it's basically visible, because it steps around so far down in space, and the Milky Way has synced the gravitational influence. Watch my time here, 7 minutes already. This is the new picture of the Euclid Space Telescope. This Able Galaxy Cluster 2390. It's like 8 megabyte camera and near infrared, so visible infrared. And I have put on a previous video this tube-shaped bubble universe that we're in. You'll have to refer back to the video because I don't want to go back to the slide. Oh, that's actually the next slide. But there's a tube going right here in this picture, which is the middle, which is the singularity of the bubble universe. I'm not necessarily saying the bubble universe is a black hole, but there's a singularity, so every black hole is different. Instead of being a black hole where everything falls in, it's more like things get built on top of the space-time, and it holds time and space-time in a shell, which is basically what a black hole does also, but we'll get some more on that in the next slide. In this light ray that I saw, I was able to see right here, there's space-time growing around the singularity, and there's gravitational lensing around. There's so space and galaxies in space-time, and it's curving the light in the image. So it looks like there's galaxies. It doesn't look like there's a tube there, but it's bending the light around the tube. And right here is a reflection of the Milky Way. You can see it in JWST also, which also shows the galaxy with its debris trail, just looking at the same spot, same thing. So this tube goes to about right here, and space-time is built up right here. This is the left lobe of the little universe. It's the right lobe, where Able galaxy clusters. So the right lobe is very cold, and there's no galaxies forming there anymore. And it cools the left side of the lobe of the universe, observable in the universe. Like I said, we can't see out of it because there's a shell around it that keeps light flowing and gravity inside it, so we can't see unless someday we're gonna get better technology, we'll might be able to see some faint. I'll let next slide. So this is the left lobe that we're in, and the right lobe is colder, and so two goes to the right here where space time is built up, and so the left side is over here, and right side is over here. We're looking at it sideways. The universe two goes this way. It's kind of like diagonal, and down here is the Boots void. The great attractor is somewhere out here. It's invisible. It's being able to galaxy. It's all that whole bunch of space time, a bunch of arms in the Milky Way. We just have a bunch of arms. Right here, this galaxy is like the space time around it. It's basically where the left lobe starts, and the left lobe, right lobe. From our perspective, it's just point being there's a landscape here. See, there's like a hill. This is the great void in between us and Able 290. The space time goes down like this, and the hill, there's another reflection of the Milky Way right here. And it goes down, and then the Milky Way is on the hill, it goes down, and then the galaxy cluster is basically right at the end of the hill, and that's why it's a reflection. The light comes up this hill all the way here, and these stars are right at the very edge of the Milky Way. They're like lone stars, under the influence of the gravity of the Milky Way. And so this landscape comes like this. There's a tube here, and there's still a lot of room down here, but Boots Void is down here where there's no galaxies, and this is it comes up like this landscape, and then down here it's all through the left lobe, really warm new galaxies, and here you can start seeing towards the front of the local universe. Stuff that I'm trying to get attention scientists. And this is kind of hard to see. This is a dual slide, so it's the best I can do for now. It would be a tube, just a regular tube with this tube in the middle, but it's warped and powerful, and it makes this shape around like this. There's this an event horizon right here where the early universe grew from a space sea right here. The early universe to 400,000 years old grew up this way, and then it collapsed on itself, forming a singularity, which is only this big. And so since then, the universe has expanded all this time. This is the modern universe from this time forward, and it's expanding at the front, but it's bulging at sides. And when the modern universe first came about from the early universe, black holes formed, and that's where all the galaxies come from. Like all the black holes that we have are already formed. Then we can still get like jet slot machine. And new galaxies that are formed now come from dark stars. Basically, they're kind of new black holes, but they're already down at the bottom as dark stars. So there's just a little pebble in space, basically, like a little dip with a little bulge. And like that's where the dwarf galaxy came from, because we're ready to see that through light in 14 minutes. So, all right. This is a simplification of the Milky Way. There's stars in here, there's giant stars, and this one gets fed continuously. This is a very outer arm. there's weak nuclear interactions going on here. This is gold, so it's way down to help stabilize. And the dwarf galaxy over here to help stabilize. And the center region, it's just perfectly even, just like a well machine. There's a break right here because these arms are on one side, and then the dwarf galaxy balances out on the side. And this arm is a broken arm, everything's frozen in time. Like literally, like time is just paused. Like a person will just be frozen there. This is Orion, and the reason why there's so many stars like star forming region, well, it's at the very edge of the habitable zone. And so the arms are pulling stuff around it, and but the center is the most powerful region in the Milky Way. And so the arms are pulling this away, but the center is pulling this way. And so stuff gets caught back in the arms, and then what the center influences is called scalar. It blows back as wind. Very powerful cosmic wind, always blowing through there. So stars, a bunch of stars form, but they never fully form. Maybe I'll just break this up into two videos, so I'll just have to make this the second part. So this is Orion, and this is like really what it looks like. The colors is just it's more like this big in comparison to the rest, but everything else is pretty much in proportions. It's going way up into the sky or way up top. And as I mentioned before, the reason why I had to actually slow down the light, I had to focus to be able to slow the light way down in order to focus on visible light. And I have a region obviously just where visible light slowed down. Okay, well that was right in front of me. But what's interesting about Orion, this is what gave me the idea to do this video. Well, a place to start because I want to do it anyway, is just explain Orion because people think stars forming, these stars are forming to become full-fledged solar systems, but they're not going to. Their stage they're in. They're stuck in a stage because of this cosmic wind. It's really, really strong. So those photos with JWST and Euclid are these gas clouds right here. So our heads right out here, and they're just blowing this way. And the galaxies rotating this way. So these are all cosmic winds, and there's basically not that much in this region, just a lot of gas, cosmic wind, not gas wind. And it's interesting because the pylades form right at the very edge. Well, it's where it calms down. And so the pylades are so huge and beautiful and peaceful because they're fed by this cosmic wind that they were. And they slowed down so there was enough cosmic wind to blow all the gas and dust away. So it's so clear, it's so crisp and beautiful and huge. And so these stars in here are continuously being fed from this arm. And so stars in here might last for as long as the Milky Way lasts. Some huge stars. And the blue is like basically colder. This one's actually gold colored, and it's we don't want to line the gold there. They're making space because it keeps the Milky Way. There's no wobble, and that is necessary for the habitable zone. There's just a bunch of rocks, there's a bunch of nebulous gas on the side. And so what we see when we look at the Milky Way is we see this, the light from this gold, but this is like all that dust and gas that we see right in our plain view. And there's just a bunch of stars in this way. And behind Orion, it's really cold, and there's like a void in there. So there's like a sun, and where fission is actually taking place, it's like a nuclear fallout. Like it just looks like a nuclear bomb does when it explodes the fallout. It's behind Orion here. And so this nice even where they think Sagittarius are like full of Milky Way is a bunch of stars right near this area. That rotation that we see is just like this big. And they think the black hole is inside there, but the black hole's way down here. It's just like the dwarf. Black hole comes down, the Sagittarius star, black hole's about this big. Like this big. If we were to be seeing it. And there's a bunch of stars, and those ones are actually between where the particle ones that survive and the ones that just like they got the idea for Sagittarius, and they started orbiting, but just going around circles, or not orbiting anything, but it is from the influence of Sagittarius because it's right at the edge in this area. And these are just rocks and dust and gas, and they're just perfectly even, like trains. And the Earth is about where I'm sitting over here. I wish I could point out more like star clusters, but I was seeing like a light ray was up from the Earth. So I only recognize pylades, so I right here. I don't really know any clusters. 2 minutes, so 6 minutes in the second video. This, if you recognize what these are, this is what our local universe looks like from a distance. This is the next level of the universe. And this is our local universe right here is magenta. Magenta. I've been still working on these videos, so I'm going to edit that and make it brighter and easier to see. But there's these groups, so we're in this group. There's a little universe of stars that's green, and that might be where we get the potential alien type stuff from because it looks like a green alien light, but there's no black holes or galaxies or stars here. It's just a shell, and there is a singularity like we have, but it's not two going through the thing. It's just like a hole, and it all rotates. It all gets sucked into one big hole, and so it's kind of like balanced. And why it's green, that's why I'm trying to get this knowledge out, trying to reach out to people because so gives that away. Like I don't know why it's green, but they should figure that out based on these facts. Why is one green? Why is this one yellow? And they spiral down. It just looks so awesome. It's like a dragon's tail. It looks like the one ratio, but the colors are pretty accurate of like which one they go down. And so we're actually at the very top. Probably because of heat, I think. But this one down here is purplish. I'll show why I like purple. This one's red down here because it's got heat, but it's not very much. And so there's another group, like I'm talking gazillion, like trillions and trillions of light years in between these things, these groups. And so there's 5 or 6 groups of these in this layer of this. It's just flat, like this is flat. This is energy. I call it the egg universe, but up here there's a lot of electrostatic electricity. Like I saw a giant when the light ray hit this area, a giant lightning surge of energy of probably electricity came from this area. And there's basically electrons. These are where some of the constants come from. Like there's an electron machine basically, and there's like a quark. I mean, it's just all mixed up. But the reason why we have electrons in our local universe, and the reason why it's also fine tuned is because there's a bunch of energy clouds inside of this, and it's not in this photo, but the space time is general relativity. So the space and the time relative to if you're going really fast in light wave, faster than the speed of light, possibly is bigger. Relativity is going to skip over all the small stuff and see small energies, but not as much detail of the actual space. But this is like what a spaceship would see, like a big light speed. Down here is gravity is still working here, and so it's green. Whenever I saw it's green, it was like slower, very cold, like he wouldn't want to be there. But it's basically the same dynamic. And at this point, the light ray came out of the universe. It was accelerated by the Milky Way, accelerated by the universe, and shot out, and accelerated by the egg universe, which is the second level universe. So it felt three stages higher. So there's a bunch of those inside this part. 26 minutes. So this will probably have to be the beginning of video 3. So these egg shapes, there's like I don't know, it's not about 10 in there, but these look like gears, but they also have colors of just a firestorm light inside here. But these all have different energy levels and different like quantum mechanics. It's like literally quantum mechanics. Like these actually look like gears. Why they look like gears is another one of those things that my brain. I mean, it was real. It looked like gears, and so it could have been making sense out of what I was seeing. But I think that they actually had gear-like things, and we're talking about like billions and billions and probably trillions of years before our sun ever existed. We're talking about such large spaces. It's probably 10 to the, I guess 10 to 25 billion, or 10 to 25 years, like or I'll say 10 to the equal years old this is. So he rises. There's a bunch of again time probably goes by a lot faster in these other areas. And this actually works because there's the stuff down here gets recycled, and this works like it's kind of cycles matter and so it makes these rings. So this is the fourth. There's a third level universe, but if I count the Milky Way, it's like 4th stage. And so that's what's there is accelerated there. This is the next stage up from these. These are all gear universes. There's like groups of gear universes in like this. There's a bunch of these gear universes, and I tried my best to articulate this. This was another flat layer. This is a flat layer. It's not round. It's literally flat. And then there's a and inside this like egg shape. And this is so huge that to get the scale right on this, it's so out of control. I'm reading this, so I have a script where I can really think about some good vocabulary words. It's elegant, eloquent, I mean, it's slick, it's savvy, tech savvy. I mean, just the proportions. You know, it's a small little strip, but it's so long. It's like one of those really, really long, sleek cell phones. Um, and this is, and I didn't paint it, but there's a bunch of these in basically like a C, and then there's a larger structure like a torus, and that's what I would consider our universe. And there's a whole bunch of these, and they all have like galaxies, broken or different units. And some of them are just big, huge, giant balls of energy that just go around different sorts of things. There's just all kinds of different things out there. There's different planets with different dynamics. And so this is coming back. I was able to control light ray, and I got accelerated way, way far, and then I had to come back because I was losing my angle. I know what happened if I get my focus back and not see from the perspective of light ray anymore. And so this is the solar system. It's shaped like a wine glass, and the solar system's just at the very bottom. So this is looking down into it, and Voyager left out to the side or something. But all the energy, all the sunlight eventually fades out up here. And there's a gravity formula, and the gravity formula calculates to the very edge of this. And I can't figure out the gravity formula myself. I mean, I need to be trained. I tried, and just joined a class in college, it was too much. I need some more training, but I know that's it because I was able to recognize it when I saw. This is just the edge of like a wine glass. And where was I now? So the North Star was here, but they changed it, and it literally, like the Earth, literally was like not as much as it was. This is now. So the North Star did actually used to be right, like looking at the edge this way, but and they changed it, so it's sort of out this way. But the solar system is at a slant. It's like a wine glass, but it's slanted this way because the pull of the Milky Way is making it slant. But if you think about this disk and there's gravity that pulls down on space time, that's why it's a wine glass shape. And it's the same with stars. All their stars are. And I've tried to explain this to any notes to scientists, and I haven't had much luck. I'm still working on it because stuff is important. I mean, if we're gonna ever get into interstellar space, I think we have to fly up. Overcome the gravity and fly up this way and out. And I think if we do, then we can travel really, really fast because the gravitational shape of the small habitable region, and all of a sudden, your star, it's just like a stone's throw away. And I believe this is the last slide. Yeah. So I kind of explained in sequential order of what I saw. I want to explain some really interesting, valuable stuff here. So thanks.